Have you ever looked at a complex machine, a breathtaking piece of art, or even a meticulously coded software program and wondered about its origin? What if the most intricate, information-rich system we know exists not in human creations, but within every single cell of your body? Prepare to embark on a journey into the microscopic world of DNA, where a digital code whispers profound truths about the universe and our very existence. For millennia, humanity has grappled with fundamental questions about our origins. Is the universe a product of blind chance, or does it bear the unmistakable signature of intelligent design? Philosophers and theologians, from the ancient Greeks like Plato to medieval giants such as Thomas Aquinas, have pondered these mysteries. They developed what we now call the argument from design. This argument posits that the intricate order, purpose, and complexity observed in the natural world are best explained by an intelligent cause rather than random processes. It's an intuitive idea, often sparked by the sheer wonder of nature. Historically, these arguments often focused on the macroscopic world, the precision of planetary orbits, the delicate balance of ecosystems, or the astonishing complexity of an eye. While powerful, these observations were often met with counter-arguments suggesting that natural selection or other undirected processes could account for such apparent design over vast stretches of time. However, the landscape of this debate dramatically shifted in the mid-20th century. A revolution in biology began to unveil secrets at a level of detail previously unimaginable. This new understanding provided fresh, compelling evidence that has reinvigorated the design argument, moving it from philosophical speculation to empirical observation. The year 1953 marked a pivotal moment in scientific history. Researchers Francis Crick and James Watson, working at the University of Cambridge, made a groundbreaking discovery. They elucidated the double helix structure of the deoxyribonucleic acid molecule, famously known as DNA. This wasn't just about a pretty shape, it was about understanding the very blueprint of life. Their discovery revealed something far more profound than a mere chemical compound. They found that DNA was not just a structural molecule, but a carrier of specific genetic information. This information, crucial for all life, was encoded in a remarkably sophisticated manner. It was, in essence, a 4-character digital code. Imagine a language built from just 4 letters. In DNA, these letters are 4 chemical bases: adenine, A, cytosine, C, guanine, G, and thymine, T. The specific sequence and arrangement of these 4 chemicals along the DNA strand contain all the instructions necessary to build and operate a living organism. This was a revelation that transformed our understanding of biology forever. This digital code isn't just a random jumble. It's a highly organized system. These sequences provide the precise instructions needed to assemble complex protein molecules. Proteins, in turn, are the workhorses of the cell, forming everything from the enzymes that catalyze reactions to the structural components of tissues. The concept of DNA as an information system is not a metaphor, it's a literal description. Just like the binary code that powers your computer, DNA uses a specific sequence of units to convey meaning and instructions. This genetic information dictates the development and function of every living thing, from the simplest bacterium to the most complex human being. Consider the sheer volume and precision of this information. A single human cell contains approximately 6 feet of DNA, tightly coiled and packed. This DNA holds instructions for building tens of thousands of different proteins, each with a unique 3-dimensional structure and function. The accuracy required for this process is astounding. Even a small error in the sequence can have devastating consequences. The information stored in DNA is not merely complex, it exhibits what scientists call specified complexity. This means it's not just random complexity, like a pile of bricks, but complexity arranged in a specific non-random pattern to achieve a particular function. Think of a meaningful sentence versus a random string of letters. Both are complex, but only one conveys specified information. Dr. Stephen C. Meyer, a prominent philosopher of science, has extensively explored this concept. He notes that specific regions of the DNA molecule, known as coding regions, possess this property of sequence specificity, or specified complexity. This characteristic is strikingly similar to what we find in written codes, linguistic texts, and even computer software. To truly grasp the significance of DNA's information, consider the analogy of a written language. Just as the letters in an alphabet can convey a particular message depending on their arrangement, so too do the sequences of nucleotide bases, A's, T's, G's, and C's, inscribed along the spine of a DNA molecule. These sequences convey a precise set of instructions. These instructions are not vague suggestions, they are detailed blueprints. They tell the cell exactly how to build proteins, when to build them, and where to send them. This intricate system ensures that a cell can grow, divide, repair itself, and perform its specialized functions, whether it's part of an eye, a wing, or a leg. The precision is breathtaking. The information-bearing properties of the DNA molecule are not just obvious, they are undeniable. Any scientist studying DNA must acknowledge its role as a carrier of information. The question then becomes, what is the most rational explanation for the origin of this information? Does this fact, by itself, compel us to infer an intelligent designer as the cause? This is where the scientific observation meets a profound philosophical inference. We are not talking about mere patterns or repetitive structures. We are talking about functional, specified information that directs complex processes. This is a crucial distinction that sets DNA apart from other natural phenomena. Dr. Meyer further elaborates on this critical point. He argues that our universal experience provides a powerful guide. Whether we are looking at a hieroglyphic inscription, a section of text in a book, or computer software, Meyer states, if you have information and you trace it back to its source, invariably you come to an intelligence. This observation is not a matter of faith. It's a consistent pattern observed throughout human experience. Think about it. Every piece of functional specified information we encounter in our daily lives originates from a mind. A novel comes from an author. A computer program comes from a programmer. A complex machine's design comes from an engineer. We never observe specified information arising spontaneously from random, undirected processes. Therefore, when we discover information inscribed along the backbone of the DNA molecule within the cell, the most rational inference, based upon our repeated and consistent experience, is that an intelligence of some kind played a role in the origin of that information. This isn't an argument from ignorance, but an argument from positive evidence and uniform experience. To suggest that such complex specified information could arise purely by chance or by undirected natural processes requires a leap of faith that contradicts everything we know about the origin of information. While natural selection can act on existing information, it has no known mechanism for generating novel, specified information from scratch. The information-rich features of DNA provide compelling confirmation for a profound conclusion. Our universe, and life within it, was created and designed by an intelligent agent. This isn't just a philosophical musing. It's an inference drawn from the very fabric of life itself, revealed through the rigorous methods of modern science. This scientific insight resonates deeply with ancient wisdom. The Apostle Paul, in his letter to the church at Rome, wrote nearly 2,000 years ago, "For since the creation of the world, God's invisible qualities, His eternal power and divine nature, have been clearly seen, being understood from what has been made, so that people are without excuse." Romans 1:20. This inspired utterance, penned long before the discovery of the double helix, seems more obvious and empirically supported now than ever before. The intricate design, the digital code, and the specified information within DNA provide a powerful testament to these invisible qualities. It's as if the universe itself is speaking, and DNA is its clearest voice. The argument from design, once based on macroscopic observations, now finds its strongest ammunition at the cellular and molecular level. The sheer elegance and functional complexity of DNA's information system present a challenge to purely materialistic explanations of life's origins. It invites us to consider a deeper, more intelligent cause. The discovery of DNA's digital code is not just a scientific triumph. It's a profound philosophical and theological revelation. It compels us to look beyond the observable mechanisms of biology and ask about the ultimate source of life's foundational information. The evidence points not to random chance, but to deliberate design. This understanding has significant implications for how we view ourselves, our world, and our place in the cosmos. If life is built upon an intelligent code, then the universe is not a meaningless accident. It suggests purpose, intention, and a mind behind it all. This perspective offers a rich framework for scientific inquiry, ethical reflection, and spiritual exploration. The debate about origins is far from over, but the evidence from DNA has undeniably shifted the conversation. It provides a robust foundation for those who see the fingerprints of a creator in the natural world. It challenges us to consider that the most fundamental building blocks of life bear the signature of an intelligence far beyond our own. The intricate digital code of DNA presents a powerful case for intelligent design. This isn't just a theory, it's an inference drawn from the most fundamental discoveries in modern biology. We invite you to delve deeper into this fascinating intersection of science and philosophy. Explore further. Research the works of Dr. Stephen C. Meyer and other proponents of intelligent design. Discuss, share this video, and engage in thoughtful conversations with friends, colleagues, and fellow truth seekers. Reflect. Consider the profound implications of DNA's information for your own understanding of life, the universe, and the possibility of a creator. Your journey into these questions is just beginning.